Now we are going to look into another numerical problem in the chapter current electricity, which comes for NCERT 12 standard. So the question is a copper wire. Cu is uh, the symbol. Actually, it is a symbol of copper, right? A copper wire of 10 power minus 6 meter squared area carries 2 amperes. If the number of electrons per meter cubed is 8 into 10 to the power 28, calculate current density and average drift velocity. So they are asking you to find current density and average drift velocity by giving a copper wire with its area dimension as 10 to the power minus 6 meter squared, and they are telling that this copper wire carries a current of 2 ampere, and they are also giving an information about the total number of electrons that is passing, that is 8 into 10 to the power 28. So now we should calculate the current density, average drift velocity. So let's get started by finding the first parameter, that is current density, right? First quantity. So what is current density? Current density, okay, this is current density. Current density is denoted by the letter J. Okay, it is capital J. That is current density. This current density J is equal to I divided by A. What is I? I is the current and A is the area of cross section. Okay, the area of cross section of the copper wire. Right? What is I? The value of I is given as 2 divided by area of cross section is 10 to the power minus 6 meter squared. So it will be 10 to the power minus 6 meter squared. So what I'm going to do is I'm going to bring this 10 to the power minus 6, which is situated in the denominator, to the numerator. So it will be 2 into 10 to the power 6. Okay, this is the value, 2 into 10 to the power 6. Now, how about the unit? How you will put the unit? We know current density is nothing but the ratio between the current and the area of cross section. So the unit of current is ampere, and divided by area of cross section will be expressed in meter squared. So the unit is ampere per meter squared. Therefore, the current density J equal to 2 into 10 to the power 6 ampere per meter squared. Okay, this is the value. So we have found the first quantity, current density we had found. Now we need to find the average drift velocity, which they had asked in this quantity 2. We need to find. So how are we going to find this average drift velocity? So now I am going to rub this one. Okay, so we have found the value of current density. So I am going to write it as J equal to 2 into 10 to the power 6 ampere per meter squared. Okay, this is the value. This is the value which we have found just now. So average drift velocity is left. So we know that J equal to, that is current density, can also be expressed J equal to N E into V suffix D. Like this also I can express the current density. So what is this N stands for? N stands for number of electrons. So number of electrons is, we have got the value as number of electrons is 8 into 10 to the power 28. What is E? E is nothing but the charge of an electron. The charge of an electron is nothing but 1.6 into 10 to the power minus 19 coulombs. Okay, and what is Vd? Vd is the quantity that we are supposed to find. We have already got the value of current density, that is J. So with all the three quantities in hand, it is easy for us to find the fourth quantity. Okay, so Vd can be expressed as Vd is equal to J divided by N into E. What is J? J is 2 into 10 to the power 6 ampere per meter squared. So this is 2 into 10 to the power 6. 2 into 10 to the power 6 divided by, what is N? N is the number of electrons, that is 8 into 10 to the power 28. 8 into 10 to the power 28 into, what is the charge of an electron? Charge of an electron is nothing but 1.6 into 10 to the power minus minus 19 coulombs. Okay, this is the value. So J is the current density 2 into 10 to the power 6 divided by the number of electrons, that is 8 into 10 to the power 28 into the charge of an electron. Charge of an electron is nothing but 1.6 into 10 to the power minus 19 coulombs. So what we have to do is we need to simplify it. Take 2 divided by 8 into 1.6 into 1.6 into 10 to the power 6 divided by 10 to the power 28 into 10 to the power minus 19. Okay, if I put like this, now the value is 2 divided by 8 divided by 1.6. 2 divided by 8, 2 divided by 1.6 is nothing but 0.1562. 0.1562 into what is 10 power 6? This one, 10 to the power 6 will be here like this. 10 to the, I'm sorry. So 10 power 6 is 10 to the power 6 will be there in the numerator. So 10 power 28 into 10 power minus 19. So 28 minus 19. 28 minus 19 will be 9. So divided by 10 to the power 9. So it will be 10 to the power 3. If I bring it to this side, it will be 10 to the power minus 3. So into 10 to the power minus 3. Okay, so this value is 0.1562 into 10 to the power minus 3. Now I can also write it as 15.62 into 10 to the power minus 5 meters per second. Okay, so this is the final result. The final result is we are getting 0.1562 into 10 to the power minus 3. Instead of 10 to the power minus 3, I am expressing the required result in terms of 10 to the power minus 5. So for getting for 10 to the power minus 5, I need to shift the decimal point towards the right hand side. So if I shift it towards 2 places towards the right hand side, I'll be getting 15.62 into 10 to the power minus 5 meter per second. Why I'm putting meter per second? Meter per second means they are asking me to find the value of average drift velocity. So the word velocity comes means the unit will be meter per second. Okay, so 15.62 into 10 to the power minus 5 meter per second is the value of average drift velocity, and for current density the value is 2 into 10 to the power 6 ampere per meter square. Okay, that's all guys. Thank you.